We next look at a very important principle when talking about wave optics. We're talking about how light behaves as a wave, and that's Huygens' principle. Huygens' principle states that every point on a wavefront acts like a source of wavelets that spread out in the forward direction at the same speed of the wave itself. And whatever time later you decide to look at the wavefront, the new wavefront is the line tangent to all the wavelets. So what I mean by a wavefront? Well, your book talks about a transverse wave, like ocean waves. If you look at ocean waves from the side, you see the transverse wave motion as you enjoying a nice time in the Noah's Ark wave pool or in an ocean or a lake big enough to actually have waves. You can see those waves come by. But when looking up from above, I can't really draw in 3 dimensions. So what happens is we draw solid lines to represent the peaks of the waves. Here the waves are moving in this direction at velocity v. Here the waves are moving in that direction at velocity v. Here's the top of your head looking down. So that's how I would represent the water waves. These are called wavefronts. And then those wavefronts move toward the beach. Now for light, these are the electromagnetic waves. This would be the electric field as it moves to the one direction or the other. Huygens was the first to put forward the idea that these wavefronts are actually composed of a lot of little tiny point sources. And by a point source wavefront, imagine a still pond where you drop a pebble in. You get that spreading out of the waves. You've probably seen it, drip a drop of water from the faucet in a still sink. You can see the ripples moving outward in a big circle. Well, if you break up the wavefront into millions and millions and millions, and I don't have the time to draw all of that, so I've broken it up into about 8 here, 8 to 9 little wavefronts, and treated those as the pebble drops, you can see how I've drawn circles around each of these waves. And like a pebble, when it drops, those waves spread out at the same speed these wavefronts are moving forward. So sometime later, all the wavefronts, the line tangent to those wavefronts is that original wavefront moving to the right. Well, why do we care? Why does it matter that Huygens' principle works? Well, let's go back to waves. If you've ever paid attention if you live near a large body of water, up north on a lake on a windy day, there's some waves moving in. You'll notice that those waves, when they hit a pier, there's a shadowing effect behind the pier where the water is still, but not completely so. So for example, if I have the wavefront moving here and I have, let's draw it in red, some kind of a pier or blockage in the water, right? Those wavefronts, these wavefronts can't move through that material because it's not liquid, right? But when it gets to the other side, the wavefronts that pass by are there, but there's a little bit of a shadow, but you can see the wavefronts curve around. You can still get waves in this area. Now, that's only true because of understanding of Huygens' principle. If each of the wavefront responds as little tiny points, and the waves move out from those points, down here, where there are no more wavefront points, it's blocked off, there's no more interference, so you get that circular bottom of this wave expanding outward, creating these curved features. I have it drawn the same thing over here. So you have the wavefronts moving, they hit a pier. Now the wavefronts that miss the pier move on in a straight line, approximately, they're not slowed. But Huygens' principle states that the points near the edge act as a point source of the wavefronts moving outward. So basically the wave turns the corner, if you will. Some of the wave actually goes into that shadowed region. Waves can bend around corners or edges. The process by which waves bend around corners or edges is understood through Huygens' principle, and I will post a link to an app that shows you Huygens' principle in terms of reflection and refraction. Your book talks about that in this section as well, but it allows you to do step-by-step applying Huygens' principle to see how that works. It gets quite complex in the end, but it's a nice step-by-step tutorial. The process by which the bending of light waves around an obstacle or an edge is called diffraction. So refraction, if you remember, is the bending of waves or light waves as it moves through material of a different index of refraction because the speed of light slows. Diffraction is the process of bending light around an edge or around a corner. Light does this, sound does this, water waves do this. Waves in general all follow Huygens' principle. And that allows us to understand how those waves bend around the corners. So again, diffraction, the bending of a light wave or a bending of a wave in general around a corner or an edge of an obstacle.